All right, so I'm going to do a video tonight called Logarithmic Differentiation Part 1. Okay, Part 1. I'm actually going to do a couple of these because it's something that comes up a lot in calculus. A logarithmic differentiation is something that comes about quite a bit. So here goes. Recall that the derivative of e to the x is e to the x. That makes it kind of a special function in calculus. And the derivative of ec to the x is c times ec to the x. So a constant, e to the 2x, e to the 5x, anything like that. That constant's going to end up coming down here, and that's the polynomial rule. There's a proof for that, but we won't get into that tonight. Okay? Now, let's say I wanted to find the derivative. Okay? I want to find the derivative of the natural log of x. Now there's a rule for this, but I want to show you how to find it. Okay, so here's what I'm going to do. I'm going to say f of x equals ln x. Now, instead of taking the derivative of this, which would take the derivative of this, right? Whatever you do to the left, you got to do to the right. Well, I don't know this derivative. That wouldn't help me. Instead, I am actually going to rewrite this as an exponential function. So what I'm going to do is I am going to take both sides, and I'm going to say e raised to the f of x power and e raised to the natural log of x power. Now, e and natural log are inverses, and so here's what happens. I get e to the f of x power equals, and e to the natural log of x is just x. Now I'm going to differentiate, okay? So now I'm going to take the derivative of both sides. Now, the derivative of x is simply 1. And the derivative of e to the x, right? E to the x is e to the x. And the derivative of e cx to the cx power is ce to the cx. Well, what is this? I don't really know. So I'm going to use my trusty friend, the chain rule, and I'm going to call this e to the u. I'm going to call that e to the u. Well, what is the derivative of e to the u? Well, if the derivative of e to the x is e to the x, the derivative of e to the u is going to be e to the u times u prime. Okay? Well, e to the u is e to the fx power, and since u was equal to f of x, u prime is going to be f prime of x. Okay? So far, so good. Now, here's where it gets a little tricky. Here's where it gets a little tricky. We're going to substitute. Come back up here. E to the fx power was equal to x. So I'm going to take this guy and substitute x. Okay? Now, solve for f prime. Okay? So, that is my version of the proof of this rule, which is d dx ln x is equal to 1 over x. Okay? Oops, my pen grabbed my paper and pulled it clean out of the view there. Okay? 1 over x. So, the derivative of natural log x is 1 over x. Fun little proof if you ever want to play around with a little bit of math. Now, what do we need to know that for? Well, if you're going to find the derivative of anything that has a logarithm in it, you got to know that rule. Okay? So let's take a couple of problems here. Okay, let's take a couple of problems here. Okay, so find the derivative. Okay, find the derivative. All right, cool. Find the derivative. So the first problem I'm going to ask is natural log of 9x. Okay? Natural log 9x. And the first thing you've got to do is realize I've got to use the chain rule. So I'm going to rewrite this as natural log of u. Natural log of u, where u is equal to 9x. Okay? Now, what do we do? Right? What do we do? Well, we're going to take the derivative. What is the derivative of natural log u? Well, the derivative of natural log x is 1 over x, so the derivative of natural log u is 1 over u times what? U prime. So that's going to give us 1 over u times, and u prime, if you've seen my chain rule video, and if you haven't, you've got to see it. You have to know the chain rule to do this, is going to be this guy here's derivative. Well, what's the derivative of 9x? It's just 9. So our answer is 9 over u. Well, what was u? 9x. Oh, well, that's just 9 over 9x, which is just what? 1 over x. What if I have something like x to the 4th ln x? Okay, what if I have something like that? Very similar to a lot of things that we've already done. If you've watched any of my other calculus videos, you've got to recognize that you have quantity A times quantity B. Okay, quantity A times quantity B. So this is A and this is B. And that derivative is going to use the product rule, which is A prime B plus A B prime. Okay, so if we apply that rule, the derivative of x to the 4th is 4x cubed times ln x plus copy x to the 4th b prime, right? This will be ln x. What's the derivative of ln x? It's going to be 1 over x. Okay, well, x to the 4th divided by x, that's going to be x cubed. And then here, this will be 4x cubed ln x. Okay, and I'm going to factor out an x cubed from both of these. And so I get x cubed times, and what's left is 4 ln x, 4 ln x plus 1. And that is our derivative there. And these get a little uglier. You'll see. These get a little uglier. Let's play with one more. Okay, let's play with one more. Let's try this guy here, which is ln of x squared minus 7 over x. Now, a good student will be tempted to use the quotient rule here. Please do not use the quotient rule here. The quotient rule should be used for algebraic expressions. You do not need the quotient rule here. We are going to instead use log properties. Remember, when you have a logarithm of a quotient, you can rewrite that as the natural log of x squared minus 7 minus the natural log of x. Okay, remember that. Okay, now, because this is a logarithm, I can do that. That's part of logarithmic differentiation, is you get to use log rules, not algebra rules. Okay, and what do our derivatives rules say? If you have addition or subtraction, you can treat this and this as two separate problems. So the derivative of ln x is 1 over x. That's easy. And this guy, I'm going to look at him as ln u. ln u. And his derivative is going to be 1 over u times u prime. Okay, well, 1 over u is going to be 1 over x squared minus 7 times u prime will be the derivative of this, which will just be 2x. And then that'll be minus 1 over x. And if I go ahead and put that 2x here, I get 2x over x squared minus 7 minus 1 over x. And unfortunately, depending on who your teacher is and what they kind of expect of you, they may or may not make you put these two together as one quotient. If they do, then you've got to do a lot of extra work. I don't. And so for me, with my class, this would be finished. Okay, so it'd be 2x over x squared minus 7 minus 1 over x would be our derivative. Okay, so a lot of fun. Definitely something interesting if you're interested in it. A lot of these problems do use their log properties, and I'll go over those in my second video. And in my second video, I'll do a few that require a few more log properties. Okay, so I hope it helps you. Please like and subscribe, and I appreciate your support.